Hey, what's going on, folks? It's Mike here, and welcome back to my Modern C++ series. In today's episode, we're going to be taking a look at some of the range functions, things that help us navigate maps, unordered maps, tuples, these types of functions. So we're going to be looking at keys, values, elements, and so on in the range function. So let's go ahead and jump into the CPP reference website here, and we're going to go down to the ranges library here, which I've highlighted, and let's just go ahead and scroll down a bit and find some of our handy functions here. And again, as mentioned today, we're going to be looking at these sort of functions here, things to deal with values, keys, and elements. So I'll just go ahead and highlight those. Now, the basic idea here, let's go ahead and just open those up here, is I want to, for instance, in keys, be able to look at something like if I have a map or unordered map and be able to gather those keys here. And this also works if I have a collection of tuples, for instance, that I could look at some key there. In fact, I believe this is a alias for elements, which we're going to look at. And again, of course, I have the values view as well. So let's just go ahead and take a look at one of these, and then we'll go ahead and start coding up an example. And as always, let's see here. I've got keys and the keys view here. Since C++20, so it takes a view of a tuple-like value. So again, it could be a tuple or a pair. And again, we're going to start with the looking at something like an unordered map, and it produces the view with a value type of the first element of the adapted view's value type. Okay, and again, this is a specialization of elements view, so we'll look at that as well here. But let's go ahead and just take a little bit of a example. And this is actually pretty much the example that we want in the notes, where we have something like a map, which consists of a key here, like the string, and the value. And I might want to iterate through this map by just looking at, well, the keys here. So this will print 1 and 2. And then I could do something, I could build up something with that actual key, like maybe I would want to sort it. Now, that's a little bit redundant in the case of a map, so a little bit of your data structures test here. And of course, if you haven't seen my videos on map, you can just go ahead and search for it. You of course know that a map is sorted by its keys. So again, check that out here. And again, you can always check out course.m.io to find out all those awesome C++ lessons. But anyways, let's get back to it. Skip the commercial there and go ahead and just try this example out. So let's just try to recreate this. Let's see what other example that CPP reference provides. They're already jumping in here with a tuple. We'll do that in a moment here, but let's just start simple with this example here, and we'll kind of continue building up to it. So again, this is stuff found in the ranges library. So let's go ahead and include ranges. I'm going to go ahead and include print here because I like using print now on C++23. You can use cout if you want. Let's go ahead and include, let's do unordered map here. Just because I think it'll make more sense if we want to sort it and use some of the different range things that we've been using in the range library. So let's go ahead and start off with a little example here. So let's just create an unordered map here. See if I can spell it correctly here, unordered map. And it should consist of some sort of pair here. So I can pass in, let's say, yeah, let's use a string and let's use another string here. Let's just do the classic sort of like dictionary example here. Let's go ahead and make this just a little bit bigger so you can just see how I'm defining things. So let's go ahead and do something like that here. Now, let's actually open up unordered pair just for a moment here. Or excuse me, unordered map, just so you can see what that signature looks like. Right, we've got the key, we've got the value here. And then we're just going to accept whatever the default hash is for the string, right? We'll trust the standard library on the implementation. So a few different ways that I can set this up here. We'll do the classic like dictionary, a small animal that meows or something like this. Okay, and this should be a key value pair. So let's go ahead and wrap those up together here. Let's go ahead and make sure this compiles, see if I made any silly syntax mistakes. I did not, so we can go ahead and populate this with a few different animals or something like this here. Let's do dog, cat, cow, something like that here, okay? And then, again, if I was going to iterate through this with a range-based for loop, let's just see for all of our elements here, elements in our dictionary. Let's just go ahead and print those out. And this is where a print line really shines here. let's just go ahead and try, well, let's just go ahead and try elements here just to, let's see if the compiler throws anything at us here. Again, this might be a little bit of a review here for us. I've got the range-based for loop. This is returning to me a pair here. And what's kind of cool with print line is it, just it's smart enough to figure that out, that this is a pair here, and we're able to get these two values back here. And again, maybe a pair we can just think of as a specialization of a tuple with two things, the key and the value, but there we have it anyways. All right, and just one little like review thing here. Sometimes, right, if this is looking a little bit cluttered here, remember we can use using, and let's just call this like string, and something like this here as an alias, effectively for what our dictionary is, the type here. So I could do something like this here. Let's just clean that up a little bit here. And I always like to review a few of these things. So, these could be a few different ways to just clean up your code here. Might depend on your coding conventions for your company or your own personal style, but again, just want to leave that as an option there. Sometimes, again, I like to be very explicit with a type in the declaration, but if we're going to use this all over the place, that can sometimes be useful. So anyways, that's just another tool at your disposal. I would say in this case for primitive types, not a big deal to just use the unordered map. If you have other data structures that you're using all over the places, if you're defining, lots of custom types and stuff, then these things start to be useful. But again, try to be consistent with them if you are going to use them. So anyways, that's just a little note there. So anyways, we've already seen in this video here, the range-based for loop that's over here. That kind of does the job for us. But again, we can start doing more interesting things like, let's just go ahead and extract out using a structured binding, which we haven't really covered these too much here, but they do kind of pop up every once in a while here. So let's just do something like this, key value, and maybe I'll keep all these different versions here. And again, you can make a sort of judgment here if you think this should be by reference or so on. I'm just going to copy these because these are small enough types here. Maybe it's okay, again, for the purpose of this video. Actually, let's just go ahead and show the syntax if you want to do this by reference. So we're not modifying things, and we can avoid the copy. That should be okay. So anyways, this is what things can look like. So let me give you just a few different ways to show how to iterate here. Let's go back to our original version here, auto elements. Here is elements. Okay, you might want the more, or avoiding the copy, so you do things by reference there. So anyways, few different ways to use range-based for loops behind the scenes here to get out the data here. But again, observe in this top version here, I've got the pair here. That's what printf is kind of returning. In this one, we've actually broken down the types here, where I have cow, a small animal that, well, maybe I should make these sentences make more sense. Says, meow or something. Says, I don't know, bark. You get the idea with what we're going with here. But hopefully that makes sense that we're able to break out these elements. So, that's exactly what we want to do with this range function here that we've got here, or this view, which, let's see, the most generic one is the elements one, but let's just go ahead and try out our standard views and look at the key here. And let's go ahead and do this just a few different ways here. So standard views, let's see, keys or key, I always forget here, keys, and then our dictionary that's up here that we defined here. So let's just go ahead and say these are the keys here. Let's go ahead and hold on to that view here. And let's just go ahead and say something like K here. And let's look at our keys. Let's do the standard print line once again and print out all of our keys. Hopefully that works and is simple enough to understand. And I've got cow, dog, cat here. Okay, but now again, since I'm able to get the actual keys here and I've got this unordered data structure, then I can start doing more interesting things here. Again, I can use the pipe operator here to compose things and build this pipeline here. So let's go ahead and do, let's see what else, what did we learn before with ranges? Where was our sort, for instance? So we had ranges, sort. Let's see, do I have a view for that? What else could I compose here? Let's go ahead and Where is my sort here? Ranges, sort. Okay. Well, let's go ahead and see if we can just do our standard ranges sort. Okay, something as simple as that. Let's give it a run here. Whoops, what did I do here? So sort is not a member of standard ranges. Did I mean standard sort here? Well, again, let's see. It looks like standard ranges sort is defined in algorithm. So we need to add in to our C++ algorithm. No problem there. Let's go ahead and give it another run. Okay, so again, it doesn't quite work like this. Remember, because we've got, well, ranges sort. This is going to actually do some sort of mutation here, and we've got a view of this thing here. So how can we break this down? A few different options that we have here. Let's just kind of chop that off, and let's ask ourselves the question: can I just do something like this here? Okay, let's go ahead and let's try. Let's see what happens here. Again, pile of error messages here. So this isn't quite doing the thing that we want to do here. Because again, we've got some view. Now we could turn this view into a range here that we then sort, right? Because we got to iterate through the keys and we want to sort them and then ultimately, pass them off here. So we could use something like we learned before. Let's see, ranges 2, and then I have to decide what does that go to, like a vector, for instance. And we're gonna have to add in a vector here, so something like this. Let's see, our lines are getting longer, but let's see, does that do something reasonable? Let's see, and it does. Okay, so I've got my keys, and usually, in this kind of case here, I mean, we're bringing in a few interesting ideas together at this point in our ranges here. I've got keys, a view, which again is, kind of think of it as this, like, again, non-owning temporary thing that exists here. But when you do standard ranges too, this is like, okay, let's actually save these results out, right? So the type of keys here is a vector of whatever the type is, right? Vector of, in this case, strings, probably. I'd have to do some introspection to see if there's some weird type here. Somebody can correct me on that. But ultimately, then I'm able to sort and modify keys, okay? Now, again, just to make this a little bit better program here, keys sorted, right? Let's actually give that a name, and then I can look through this here, okay? So if you want to hold on to the result here, that's, this is an approach that you could do here. And then you sort your keys of your ordered map, and then you can iterate through them, and then do something like this here, where I then say, okay, here's my dictionary. I want to go through all of my sorted keys and look them up and return the value here. And then I have my definitions here. So cat would be first, then cow, then dog in alphabetical order here. Okay, so something of that nature here. And let's just make this a little bit more clear with some adjustments to our output there, just so you can see that they are in sorted order. Okay, so that's really all there is to it, this last run that we did here. And again, just to make this very distinct between each of our runs here and give you a little bit of time to process, I'm going to go ahead and just put in some print lines after each of these little examples that we did here. Okay, so ultimately, this is a strategy that you could use. Okay, so the other thing worth mentioning again is, the way that I did this, I'm just sorting the keys and storing the result, and I'm not modifying the dictionary when I do that. Okay, so that's again one of the things to think about. If I just wanted to actually modify this, then I could have run like some sort of sort on this, and then sort again might have some projection. So if there's other fields or things that we want to do, we can do that. But anyways, that's the idea here. So let's just kind of focus on using some of these functions here. Here is our ranges library version of sorting keys. Okay, we'll just kind of leave some spacing there just to kind of break these examples up a little bit. Let's look at the other functions that I described here earlier. So again, we've got our unordered map. We talked about sort, which we have available here. We've been looking at keys. Now let's do the same sort of experiment, but with the values here. Okay, so if I just want the values, simple enough that I can just look through the map here. Things that we have are our dictionary. And let's just print this one out, we'll just go ahead and do the, let's just look at our range here, standard, views, values, and which range do I want to look through here? Let's just look through the dictionary, the original one here. So let's just go ahead and output these. I like to use E or something of that nature here to print them out. And this is just going to be the dictionary values. Okay, so something like that. Let's go ahead and see if that works. And we can see our dictionary values from the original. We've got moo, bark, meow, and we're just looking at the original dictionary. Okay, so that's what we get here for values. Let's take a little bit of more look at this function to see if there's anything else interesting here. So it takes a view of tuple-like values here and produces a view with value type of the second element of the adapted view's value type. So it looks like, this is kind of interesting. It produces a view with a value type of the second element. So if I had something like a tuple, usually you'd probably, think of the very first thing as the key and then the rest of it. I think this is just taking the second element here. This is just a specialization of elements, which we're going to get to here in a moment. So that's the basic idea. Let's see if the example, kind of a similar example for map here, where we're just looking at the, again, the second element here. So it's going to print out alpha and beta here. Simple enough here. In this particular example, let's see here. Again, it's just got some pairs. We're just looking at the values. In this example, it's then filtering based off of the value. So again, this could be quite useful. We looked at in the previous videos things like transform and filter. So again, if you want to look through any map-like data structure, again, by key or by value, and then filter them out, well, here you go. This is kind of the handy stuff to use here. So anyways, let's get to our last range library function here. We can see the call signature here. This one, or these two pages rather, I didn't see the call signature because again, it's just a specialization of this guy here, elements and elements view here. So let's take a little bit of a look here. Again, I like to look at the call signature first to try to understand these things. And let's just focus on this function here. We're going to, we've got the concepts here and we can kind of dig through these, but basically it's just a range view. And let's see here. So it's going to take in n, some element number here. I believe that's what n stands for. And then our range. Let's see here. So accepts a view of tuple-like values and issue a view with a value type of the nth element of the adapted view's value type. Now tuple is, I suppose, strangely one of the things that I haven't covered. I'll fix that on the series. Eventually we'll get to tuple because I want to talk about tuples and ties and these types of things. But again, this is just pretty similar to the key value thing we were looking at, except I get to specify the nth element here. Let's see if there's anything else interesting here. Maybe we'll just look at an example. Yeah, we basically just need a tuple with 3 things here. So let's go ahead and let's do that here. I'm going to keep that example nearby to avoid potential syntax mistakes, but I do need to include tuple, again, which we haven't looked at too much here. And let's see, sorting keys, values. Oops, too many keys pressed. Let's go ahead and look at ranges library. Let's just call this standard ranges, standard views, elements with tuple example. And what I'm going to do here is let's just kind of copy something like this here. Let's move to the bottom of our code. And let's call this string int here. Okay, and this is going to be a tuple. And it's going to have a string, and an int for lack of better naming convention. And we'll go ahead and call this dictionary2. And let's assign, I don't know, some value here. Cats will get 500. I think that's appropriate. And cows, let's put them right in the middle there, 450. Whatever those values mean. Speed or happiness or strength or something. And let's just go ahead and take a look at this structure here. So again, similar experiment here. We could do something like this here, where I have a structured value. I'm just going to call this 1, 2, 3. And let's go ahead and look at our dictionary 2. There we are. And let's do standard print line. But again, I'm just going to be kind of explicit here. With 1, 2, 3. And let's go ahead and run this. Oops, let's see here. 3 names provided for our structured binding. Let's see, maybe I messed something up here. Oh, yeah, stir, I didn't change the type here. Int. And structured bindings are kind of cool. Again, something that I will have to make a separate video on here. Well, let's see what mistake I made here. Let's see here, count to the end. Yada, yada. Let's see, let's scroll up to the very top here. Again, some of these bugs are a little bit tricky to catch here. What was I missing? Actually, I think I'm okay. I'm just not setting up the problem quite equivalently here to what we had here, because this should be like a vector of these guys or something. So let's just go ahead and do that here. Standard vector of these things here. So, well, let's, yeah, this is okay here. I mean, again, we could probably make this a map and do something of this sort here. Let's see, I've got a vector of these 3, a vector of tuples. Yeah, this is okay. Let's at least get it compiling here. And then we can add some more complexity, but this will should at least compile things out here. Okay, so now we can at least see what our elements are here. And a similar thing here, let's go ahead and just show the view for auto elements. I'll do this right within the range-based for loop. Let's do our views, element or elements. I'm always gonna forget here. Try to avoid too many syntax errors. Elements. And again, you can just see how we access this. So again, the collection and then the 0th, 1st, 2nd, and so on element here. Let's just go ahead and look through, if the 0 element is our key, that's what it's going to be here. And this is our dictionary 2 that we're looking at here. Let's close that for loop. And let's just go ahead and say, well, let's just go ahead and print these out here. Okay. Don't really need the space here. I even set it, but I didn't do anything with it. There we go. Elements here. Okay, great. All right, so there we have it. Cat, dog, cow, corresponding to what we have here on our elements. So with that said, we covered a bit of ground here. Hopefully you see these handy functions. Again, if you're working with like a database and retrieving a record or something, right, that has multiple fields, things that maybe you're storing in tuples or structs or these types of things, or you need to convert a struct to a tuple and then access it in some convenient way. These could be some handy things that you can do here, but now you know you have the general purpose elements function here. In general, of course, if I had a map or unordered map, I would just be using the view for keys, or of course values, depending on what you're trying to do. Again, don't forget all the other stuff that we've been learning previously, where if you want to convert that view into an actual range, so then you can sort it and mutate it and remove elements and these types of things, those are things that you can do. So anyways, folks, I hope you enjoyed this lesson. I hope you learned a few things as we reviewed a few concepts here. I'll go ahead and wrap us up here. And hopefully you're enjoying learning about ranges. If you have some other tips with these functions, things that I missed, error handling notes that you want to add to the community, feel free to otherwise share those below. I'll look forward to reading those as best I can and comment as well. And otherwise, folks, I'll look forward to seeing you in the next one.